Okay, so I have a question for you.
So we have a quiz week.
Yeah, next week.
Class before a test.
2 classes. Yes, we have a review and then
This is the
quiz.
22nd and the 25th.
And we have a class. I may have to adjust it. You're right. We'll see. We may have to adjust. You're right. The review will be in between the quiz and the test. So I'll check the calendaring. Thank you. So, is this a pretty stressful time of year?
Yes.
Can you show me how many tests you have next week? Either tests or projects too, or something big next week? I'm just curious. Show me how many. Do you have 1, 2, 3? Think about it. Yeah. Next week.
That's faster. No, we're not. It's not.
Okay, so I'm saying from 2 to 5 things.
Okay. Right.
Okay. Would you show me your level of stress these days?
1 to 10.
1 to 10. 1 to 10. Oh man. Okay, so I'm seeing some 1s, but I think that might be a 6. Okay, so 6 is up to like really like not just 10, but like powerful 10.
Right.
Like a booming 10. I hope that at least helps that the testing calendar has made it so our test is out of the way for this class. I hope that has helped.
There's no quiz though.
There is a quiz, but it's a little quiz. Well, they're all same size. In any case, I do want to tell you that I know the life of a Harvard Westlake student is stressful, and I appreciate the work that you put into this class. I appreciate the way you come to class every day with a good attitude and a can-do spirit. And I really appreciate that. Even though other things are going on, you're able to compartmentalize and make it happen here. And I know you spend a lot of time. So I appreciate you and I appreciate what you do. And just for what it's worth, I see you. Let's do some distance, shall we? This would be review distance formula. Can you check it with your neighbor and see if they remember what the distance formula is? It's X1s and stuff.
Oh wait, that's good.
That's.
We right now
Yeah.
Okay.
Yes. Yeah.
Okay, so there's the square root involved. Big square root. I'm gonna put this at the end because I wanted to do some development in the middle. So save yourself some room for some notes. Square root of.
X1.
You have a set of parentheses. So the first one is there are different ways to say this. X1.
Minus X2.
I'm gonna say X2 minus X1, even though it does work out to be the same thing. And that quantity is gonna be squared. And then from here we plus
y
y2 minus y1 quantity squared. Does that look familiar? Was this in your memory banks? Well, if not, that's okay. I hate this formula. It's one of my least favorite formulas, and I'm going to show you why in just a second. You don't always have to use a distance formula. In fact, I recommend analyzing before you do anything. For instance, if you have two numbers just on a horizontal line, and let's say that this is the 3 and this is the 7. Do you see what the distance from 3 to 7 is?
Yeah.
What is it? Did you have to use a distance formula for that? You definitely did not have to use it if it's just on a horizontal line. And how about if this is -3? Suddenly this distance is 10. So we could always get that distance by doing what? Subtracting. Does that make sense? To take the uppermost coordinate minus the lowermost coordinate and just subtract. If it's on horizontal, of course, that also works if it's on
Vertical.
a vertical axis, something like this. If this is 12 up here and this is 4, and that distance, do you have to make tick marks to know that it's 8? Would it be smart to use a distance formula there? No, if it's like just on a horizontal or on a vertical, all you have to do is subtract to get that distance. The problem is when the 2 points look like what? Show me. Show me what it looks like. And one's here and the other one is like here, right? When it's on some sort of diagonal, right? That's when it's a problem. And you might try to take an axis and try to tilt it and try to figure out that way, but please don't do that. We're going to use a formula to get there. Let's say, here's my first point. I'm going to call this x1, and this is y1. So the coordinates are x1 comma y1. The next point I'm going to put like up here where the coordinates are x2, y2. So do you see what the x-axis? I'm going to mark on the x-axis there. Just below it, I'm going to write x2, and just to the left of it, I'm going to write y2. And I'm going to go ahead and draw this segment because I'm looking for the distance from one point to the next. What am I about to do here? I could use a formula, but I want to use a theorem.
Could you make it a right triangle?
Could we make it a right triangle? Thank you. Could we make it a right triangle? I may try to make a right triangle like this. That's not at all what I'm thinking of. To make this right triangle, we're going to go from one point straight down and then straight over.
It would be a right triangle if you did that, right?
It would be, but maybe not so helpful. Yeah, but I like your idea to make the right triangle. I'm going to make it right here, no pun intended. What are the coordinates of this point? Could you check with your neighbor what the coordinates of this point are?
But wouldn't it just wouldn't it
Yeah.
be
Well, let's talk about it after I finish this, and we'll see how that would be helpful. Okay, so the coordinates here, the first coordinate is, I shouldn't call it like x3, it's x2. It shares the coordinate of the point above it, x2 comma y1. Now, I may not know the distance for that diagonal, but I could say that the distance, I'm going to write it in red here, for this vertical, you see what that length is? We check to see what your neighbor says using the information you have here. You see what it is? Count of 3, let's hear it. 1, 2, 3. Perfect. Y2 minus y1. You see where I'm going with this, don't you? The other side, what's the length? Right, that bottom side, it's on the horizontal, so all we're going to do is take the coordinates. I'm going to move this because that's in the way there. What's the expression I could use here? x2 minus x1. Is that clear? Then I'm going to call that hypotenuse. I'm just going to call it D and use not distance formula, but Pythagorean theorem. D squared is equal to x2 minus x1 squared plus y2 minus y1 squared. And of course, if I want to find the distance from that equation, all I have to do is take the square root of both sides. And from that, we get the distance formula. What do you think? Does that make sense, that connection? So it's not like random letters that go places. It comes from Pythagorean theorem. So very often students say, they get to this point and think, is this plus or minus? But it's very definitely plus, and we know that because we know a squared plus b squared equals c squared. So it shouldn't be a problem to know where everything comes from. In fact, I try not to use the distance formula when I'm doing problems. Like this problem up here on the board, right? This state. We have a 9 and a 12. We know that's that third side. How can we find that thing? Well, talk about it with your neighbor. Let's make sure they know how to do this problem.
Yeah.
Your numbers are 3, 4, 5. 3, 4, 5 is called a
Pythagorean triple.
Pythagorean triple. And then the three numbers go together and fit the Pythagorean theorem, and then we just triple them. That's how we know this is 15. So very often you can just recognize what kind of triangle we're dealing with. So before I go on to a specific question, I want to go back to what I was saying to Baron, where he was like, well, why can't we just, like, if I have this point, like you were saying, why can't we just make another right triangle?
Yeah.
Like maybe like this or something, or
No,
or we,
like that's still the hypotenuse.
so like this.
Yeah.
Yeah, so we could do it, except those other sides are now not vertical, not horizontal. It's not easy to find those lengths. We want horizontal and vertical. Because horizontal and vertical, like I hope you agree, super easy to find the distance from one point to the next. So that's what we try to incorporate into this. So yes, although we could do different ones, we try to simplify things. In general, that's what it comes down to. I know it's complicated in the beginning, but ultimately, there should be free-flowing thought. Okay, so we could use a distance formula, or I'm going to imagine a triangle here. I don't know what this triangle looks like, but I know it's a right triangle. One of the sides is 4. Do you see where that came from? The other one is, do you see where that 6 came from? Would you check to see if your neighbors know where this 4 and the 6 came from?
Oh.
Four minus 6.
You see it? Because some people may do things like, oh, 1 times 4 is 4, 3 times 2 is 6. But that's not it at all, is it? The 4 comes from,
Wait, does that work though?
it just happens to be this problem.
Oh.
Right, people see patterns that I'm hoping they'll see, but they're in the wrong place. So that would be one instance here. And that this is just a special case where that happens. But the 4 came from
The distance between 3 and -4.
distance between 3 and -1. The 6 came from distance between 4 and -2. So now I'm just going to do this. What do you think? X squared equals 6 squared plus 4 squared. X equals a square root of 36 plus 16. I hope you could do this. What is this? 52? Does square root of 52 simplify?
Yeah.
Does?
Yeah.
So what? Nice. Any questions? Should we try it using the distance formula? You should be able to, or you should be able to do the distance is equal to the square root, and I'll take the x's. 3 minus -1 squared plus 2 minus -4. Is that right? 2 minus -4 squared.
-2 minus.
Oh, -2, thank you. -2 minus, oh, I got those switched up. Thank you. -2 minus 4 squared. I hope you can see that it amounts to the exact same thing. It's just an abstraction of it, but you could always get to that triangle just by looking at the coordinates. Any questions? Maybe your question is, why can't we do this even easier? Think back to your geometry class. How could you have done this a little bit easier? I know it was a while ago. A different world. Oh, I'm hearing it. I'm hearing it. So take that 6 and 4 and make them. Would it make sense to make them 2 and 3? These triangles are now similar. Let's find the hypotenuse of that smaller one. What's the hypotenuse of the smaller one? Does it make sense that this is square root of 13 right here? How would that help you get the original one?
Double.
Just double it. It's so nice. Do you like that? If you could divide through by anything, do it. Yes, it's the end of the code.
13 come from, I think.
Good question. I just heard Baron say it. I just took his word for it. He seems smart.
It's because it's on the big triangle, it's 2 root 13. So on a
Oh.
triangle with all the sides halves,
Sure.
it's half of 2.
You're just getting it from your.
Oh.
Yeah,
Oh, but how would we get it right from here?
you could also say like 4 is 13.
Yeah. X squared is equal to 3 squared plus 2 squared.
Oh, yeah.
There's a 13. So rather than use the big numbers to get the hypotenuse, you could simplify that triangle often and then blow it back.
Feel that much easier considering it requires 2 more steps.
You have to-
Well, it depends what you have 4 and 6. It's not that difficult. But if we had like 17 and 51, that might be different. Exactly. Right, bring it up 1 and 3. Try B. Find the distance from one point to the next. Find someone to help us out with that.
Let's check.
Check in with your neighbor when you are done or stuck. Did you get it yet?
Yeah.
Did you get it? Check in with your neighbor.
Oh.
I'll have Destiny choose one person. Whoa.
Why is it parents regular? Yeah, yeah, regular. I'm gonna get. Pretty good match. Oh. It's
So wait,
-3 minus 3 is not that. It is in fact -6. Wait.
Okay. Dylan, can you help us out?
Yeah, so it's, 3 minus negative 3, which is 6, and then 2.
So you got a
minus
6.
1, which is, 3,
Okay.
and then I, put distance equals the root of 36 plus 9, which is 45, and then 45 is 9 times 5, so I put 3 root 5.
3 root 5, you said? Do we agree? Any questions? Nicely done. Thank you. Of course, the 3 and the 6 could have been brought down to 1 and 2 if you wanted to. But yeah, it's not hard to simplify square root of 45 once you have facility with it. Good point. you please discuss what's the midpoint of these two numbers that I put up on the board? Coordinates of the midpoint. What is the coordinate of that midpoint? Will you please show me the coordinate of that midpoint? Show me the coordinate of the midpoint of that 2 and the 12. Coordinate, show me. Don't point at it, show me the number of digits that represents the coordinate. Yeah, so 7, how do we get to 7?
12 plus 2 divided by 2.
So the word we use would be the average, right? Midpoint will give you the average. There are other ways to do this. Some people get that distance and then cut the distance in half and then add or subtract. Average is the way to do it. So this is what I want you to think when you're finding the midpoint of 2 points. Average of the coordinates. Which means the midpoint of x1, y1 and x2, y2 is, what's the first coordinate going to be?
1/2 times x1 plus x2.
Nice. I like to think about it like this, but you're exactly right.
But it's still saying over y.
I hope you all aren't missing something back there. Yeah, again, some people think, oh, is it plus? Is it minus? I mean, is x1 plus x2, y1 plus y2 is a minus. It is a comma in the middle. But yeah, is it like, how do we remember that's a plus? Because that's how to find the average. You add this stuff and then divide by the number of things you're adding. When would it be minus? What would you use minus for? Either the distance formula, right? That x2 minus x1, or when you're finding the slope, right? y2 minus y1 over x1 minus x2 minus x1. But for midpoint, it is addition because it's just average. Okay, try A and B, please. Make sure you got your neighbor got it. Calling the couple to give us the answers. You ready? Ready or not? Ryan, can you tell us what you got for A, just a midpoint?
Yeah, -7/2. And then it's comma -5.
Negative. Are we good?
Yes.
Cool, thank you. I especially like that -4 and -6. We don't really have to do math to find that average, do we? It's the number right in the middle. If math will work, of course. Don't forget that you can use your common sense. Ivy, for B,
I got -3.
-3 comma, -1/2. Do we agree? Are we good? I'm seeing some furrowed brows.
Oh yeah, 4.
The first one is, what's the first one?
4.
Is it?
Yeah.
Are we sure? Okay, just trying to see if you're paying attention. Good job, Ivy. It was a good test. Thank you, Ryan and Ivy. Any questions? Okay, we're about to go from triangles to circles. And I'll start at 225. Let us continue. Thank you for your patience. Sorry about that. I had to take something really quickly. I think you already know what a circle is. Set of all points. What's the word? Set of all points? Equidistant. Or a given distance from a given point HK. Do you already know the equation of a circle? Does anybody know it? So the X's and Y's. Yeah, let's develop this.
Y equals.
There may be a Y. Think about it. Think it, and then we'll keep it math. What I'm going to do here is I'm going to make a triangle. Now H comma K is a fixed point, but X and Y could be anywhere that distance, that red distance away from HK. And I call that red distance R. And what should I call this distance here? Yeah, subtraction wise, what would an expression for that be? Well, let's see. Like, let me mark my x-axis first, actually. In my x-axis, what is this coordinate? That is H, and this one is X, and that's moving, isn't it? The X is moving no matter where, depending on where we are in the circle. For the y-axis, this is K, and this is Y. So my sides of the triangle, the one I was pointing to, would be, that would make sense if that's Y minus K. Isn't that the vertical distance, Y minus K? I know this is super abstract. This distance here is X minus H. So my equation for the circle, hope it makes sense, is going to be X minus H. What am I going to do with that X minus H? Squared plus Y minus K squared equals R squared. That's the equation of a circle. The center is H comma K. Notice it's not negative H. It's just H comma K. So I do need you to get familiar with that formula. It comes directly from Pythagorean theorem. It talks about all points X and Y that are equidistant from a specific point HK. So any point on that circle will fit in this formula. Standard form of a circle. We're going to multiply all these out. What do they want for standard form? This is called vertex form. Not vertex. Yeah, it doesn't have vertex. This is called center form. Thank you. Center form. There is a standard form, which is not as helpful as center form, but standard form is going to be ax squared plus by squared. Yeah. Plus cx plus, what do you think is next? dy. Plus plus e equals 0. Mostly you're going to see center form. Sometimes you'll see standard form like this. And we're going to write, now your book may be calling this center form, honestly. I'm not exactly sure what your book says. Start with center form for sure. If we know the center is 0, 0, and the radius is 2, do you know the equation of that circle? Yeah, we use our formula. X minus H squared plus Y minus K squared equals R squared. And we now say that X minus 0 squared plus Y minus 0 squared is equal to 2 squared, or X squared plus Y squared equals 4. And that is actually both, I think that's center and standard form, except the 4 is on the left side. For B, we're gonna start with X. What? X plus 2 minus -2 becomes plus 2 squared plus y minus 3 squared equals 16. And let's say we're just done with the problem. I think that when it says standard form, it's actually looking for center form, so I'm gonna leave it there.
So we could write that and it would be okay.
You'll see what the homework requires you to do. If it's requiring you to put in a different form, then you're gonna have to expand each one, combine like terms.
That doesn't.
Yeah, maybe not so much fun. Center form is where it's at. Okay, so here it's kind of very clearly that that form that we see is standard form. Okay, so we're gonna accept that as standard form. Sorry about the cross messages. Discuss with your neighbor, what is the center and radius of the circle? And go ahead and show me the coordinates of the center, please. It is 2, -4, and the radius, show me the radius, is 3. Can I answer any questions? Yeah, Mia? Yeah, I'm sorry, I'm gonna take it back. I'll say that to be consistent, it looks like this is standard form. Standard form. This may be general form. I'm guessing this is general form then.
General form comes later.
Does it? I don't know it's standard form. The important one is the one where you know the center and the radius.
Standard form, same as center form?
It's looking like it is the same thing. Yeah, I apologize. So we are calling this standard form to be consistent with the book. And we'll call this other one general form. Is there to talk about general form later? Yeah. That's my goodness. Okay, then I imagine that's just gonna go there. Okay. Graph the equation. Okay, to graph this, I'm gonna start. Well, you can graph this. I'll graph it while you graph on your own. How many points should I draw to make the circle nice and even? 4 points. You see where to go?
Are we gonna lose point of our circle if not starting out?
I want to see an honest effort. Yeah, mine sucks. I'm sorry. Circle shouldn't be lumpy like this. I will take out points if I see a rhombus. If you just connect those 4 dots, I'll take it. But if you just make any sort of effort to make it roundish and go through those points, I'll be quite happy. Oh, domain and range. Do you already know the domain and range? You show me the domain. Nice. -1 to 5. Do we include those endpoints?
Yeah.
You do. And the range begins with -7 and goes up to -1. Cool. Any questions? Example 5, use the standard form of the circle's equation to graph the circle. Oh, that's not standard form. First thing we're gonna do is divide by 3. We want just those coefficients to be 1. So we'll divide by 3. X minus 1/2 quantity squared. So y minus 2 quantity squared equals 25. Oh, that's nice. So I'll give you a moment to graph that. State the domain and range. Check with the neighbor when you are done or stuck. Yeah, I'm gonna ask someone how they graphed it. So if you're not sure, check with your neighbor. I'll give you about 10 seconds. Just want your advice on how to graph this. Okay. Emma, could you help me out here, please?
Yeah, so for the center, I have one.
Right there. Okay.
And, half.
That's ugly. Then was it 4.5? Something like that. And then you made a trapezoid. Okay, and we just make the circle going through those 4 points. Now, some teachers would say thank you, Emma. That was great. Some teachers would say that center should actually be an open circle. Would that make sense? It's not part of the graph. The only points that fit the equation are on the outside. I'm not gonna do anything like that. But the center is not part of the circle in terms of the equation.
Right.
But if we were to check all the coordinates of the points that Emma said, they would fit the equation perfectly. I'll trust that you could do domain and range on your own. So if we expand the equation, okay, here we go. Is it difficult to expand x plus 1 squared? Or not be x squared plus 2x plus 1 plus y squared minus 6y plus 9 equals 16. So general form is what I confused, and I apologize for that. That's where we put all the squares first, or the quadratics first, x squared plus y squared. Then the when the exponent is 1, what kind of terms are those called? They put the quadratic terms first, and then the linear terms, and then the constant term. So 1 plus 9 is 10, minus 16 is minus 6 equals 0. There we go. General. And I hope you appreciate that general form is not helpful. Except for one thing, we could recognize that it's a circle because it starts with x squared and y squared. By the way, please don't forget the squares. If you do, it's suddenly a line. We need the squares for both x and y. Okay, so we recognize that these are circles, but we don't know the center or the radius. I give you a chance to talk about, maybe you can think of a strategy of how are we gonna get the center and the radius if it's in this form.
Oh,
Any ideas? Yes.
I know in the first one, it's X plus something, and because it's only one X, you know that. You have 4X, you know, it should be half of that, so it should be 2X, which means you need X plus 2 squared. Because if you multiply that like that, gives you X squared plus 4X plus 4.
Okay.
Uh. And on the other
Wait,
side,
before you go on, does what he just said make sense? That was really nice, but I'm a big fan of what you just did. So you're kind of going backwards through here, aren't you? Kind of like.
Yep.
Going backwards, like if you would have just had this 2X from here, you would know that the X coordinate, you would not kind of be able to work backwards from there. I think that's what you're saying. Same thing with the Y's, like here, you would be able to work backwards to know that we have a. What process are we alluding to here? And Ben, were we able to get the radius?
I think so.
What did you get?
Um. The radius, I got.
13? Maybe, I don't know. Yes, Sienna,
Radius of 6.
you got 6? How did you get 6?
I I put them in groups. I did X squared plus 4X plus 4 plus Y squared minus 6 Y plus 9.
Okay, where did that 4 and the 9 come from?
If you're completing the square.
That's what I'm looking for. Completing the square. And Baron, I think you were knocking at that door for completing the square. Like an intuitive way of doing it, which is awesome. So I'm gonna write like this with the blanks first. Y squared minus 6Y. And I'm gonna put that 23 on the other side. I'm gonna give you a moment to complete the square. Remember how to do that? Yeah, so Sienna, you already told us we're adding what here? First one.
We're adding
We're on the left, of course, since it's an equation, we're gonna add it both left and right. We don't have to worry about function forms. We're not doing that plus minus on one side. We're also adding 9 to left and right. Let's see what we have here. So this is X plus 2 squared plus Y minus 3 squared, and this is equal to 36. Oh. Is this more helpful than the other equation? Much more helpful if we're trying to figure out what we're dealing with here. We already know it's a circle. Ernie did a great job of figuring out what that center was, but to get the rest, we just need to put all the pieces where they belong. I'm gonna trust you to be able to draw that circle, and I'm just gonna move on to the next one, if you don't mind. B. I'll let you do that one. I'll call on someone. When the neighbor, when you are done or stuck. Check in with your neighbor. Okay. Sienna, do you have any idea how to do this problem?
Yes.
I had a feeling you might. You'd help us out.
So I moved around the term, so I did x squared plus 4x, then like left it blank and did plus y squared minus 4y, and left it blank, and I said equals 1.
Okay.
And then if I complete the square, for the first set, I added 4 and added to the other side. Then, yeah, and added 4 to that one, and also added 4 to the other side again. And then I got x plus 2 squared plus y minus 2 squared equals 9. And so I got a center of -2, 2, and a radius.
Any questions? Did you already have that? Nice. Okay, well, there are some practice problems here. We're not going to do them today. We're going to wait until before the test to do those problems. I'm going to ask for you. If you want to do them, maybe do it on a separate sheet of paper. I was going to give you some time, but there's only 10 minutes left, so I'm thinking maybe have nap times. Nap time, or you could go as long as you promise to be quiet in the hallway. You promise? Okay. Have a great weekend, folks.